Studies have shown that children learn better when they are stimulated by the way that information is presented to them. It is no secret that active participation results in increased information retention. This is especially important in the age of modern technology, where it seems not much has changed in the classroom since the industrial age, where schools mimic the departmentalized nature of industries. This dated method, along with educational budget cuts in difficult times, account for the underperformance of K-12 schools according to their very own mandates. With the advancement of technology, our team believes in an integrated approach to education and chose to focus on using modern technology to create an effective and integrated education tool. Enter H.E.R.B, a hydroponic educational resource base that monitors and regulates inputs to plant growth while aggregating data and allowing the user to track and respond to trends. To develop a truly successful final product, we divided it into subsystems and performed unit tests on each system, allowing us to optimize them all before putting it together in a cohesive and intuitive final system. For our structure, we use 3D modeling software to ergonomically proportion the structure while also performing finite element analysis to ensure its integrity. By using 3D modeling, we're able to get a good sense of how the structure would function ahead of time. And with our water cycle, the water in our system is circulated in an ebb and flow water cycle. Water is pumped from down in the reservoir up into the tank, where it provides nutrients to the plants, before being cycled back into the reservoir to replenish the nutrients or simply to allow the plants a chance to breathe. When it comes to temperature and humidity, to regulate the temperature, we put a heating coil into the tub that contains the plants, which in conjunction with the strategically placed temperature sensor allows for accurate temperature control. We retrofitted a humidifier to the system, allowing us to increase the humidity at any point. Because both temperature and humidity are lost over time, we have increased control over the system. Our nutrients and pH, we kept nutrient and pH modifiers stored in tubs attached to the system, allowing us to add them to the system on demand, and making sure that we could control nutrient and pH content of the water at any point in time. After reviewing literature on the growth effect of LED lighting on plants, we were able to make use of wide-angle LEDs to produce plant-specific lighting to the system. Our control is such that we can control the individual lighting given to different parts of the system, thus allowing us to grow different plants in different locations of the same system. We attached a pie cam to the system, which, along with our image processing software, allowed us to be able to distinguish between healthy and unhealthy plants by presenting the user with an image colored green for the healthy plants and colored red, as seen here, for the plants that are dying or dead. Growth is then judged by calculating the percentage of green in the final image and comparing it with the percentage of green in the full-grown plant of that type. Pictures are taken periodically and sent to the user so as to allow the user to make changes to the system to remedy the situation, or to begin to document accurately what exactly is happening. We also did a lot of work with our database and online user interface. Putting all these aforementioned systems together required computational power, and in accordance with modern technology, we enabled the system to be controlled remotely. We set up an online server to store and display our data in a meaningful manner, allowing potential educators and students to access, analyze, and even discuss the data, while also making real-time changes to the system's behavior. All the code for this portion was developed from scratch and documented well along the way, allowing students to follow on and learn throughout the process. All the deliberate autonomy, coupled with a lesson plan of the educators creating or choosing, allows for a powerful educational tool and possibly a research tool as well. The definite intention of our design is to couple it with a curated lesson plan for increased effectiveness. To this end, we coupled with a CIS team who developed a more lesson-specific online platform for use with H.E.R.B. When small-scale tests were done by our faculty advisor, we noticed a 20% increase in the engagement of students with material presented in this manner, and we hope that this will only increase over time.